Use the experimental apparatus to find the charge-to-mass ratio Q/m of a group of particles. The apparatus consists of two charged plates with a horizontal length of 1 centimeter and a screen located at the left end of the plates. Charged particles are injected between the plates with a horizontal velocity of 3,980 kilometers per second. You can control the electric field between the plates, which can be assumed to be in the vertical direction and constant. In this simulation, you control the value of the constant electric field between the plates. The electric field will deflect the charged particles moving between the plates. Adjust the electric field until you hit the given location marked on the screen. The mark on the screen is located at 0.2 centimeters above the horizontal line at which the particles are injected. Using the value of the electric field when you hit the mark, along with the given initial horizontal velocity of the particles and the horizontal length of the plates, solve for the charge-to-mass ratio of the charged particles.
This interactive video is a question from Monterey Institute of Technology. You can Google Monterey Institute of Technology AP Physics 1 or AP Physics 2. And for every topic covered in AP Physics 1 and AP Physics 2 at the end of each video, they will have examples which every time you run this example or like this problem, it will give you different numbers. So for this question for electric fields in AP Physics 2, when I ran this question, I got, in order for the charge, they don't tell you what type of charge it is, in order for the charge to hit at 0.2 centimeters away from the center, in this electric field, you have to have the electric field strength of 18 newtons per coulomb. They also tell you that when the particle leaves the machine, it leaves at the velocity of 3980 kilometers, which is 10 to the third meters per second. And they ask you to calculate the charge per mass ratio. So that's the one that we have to find. So from the information that is given, I have the velocity. So the velocity when the charge is leaving the machine is given, the velocity, and the distance that it will travel is given. So because the velocity is given and the distance is given, I know the time. So the time is going to be equal to the distance over the average velocity, and this velocity doesn't change, the horizontal one. It's almost the same as the object accelerating toward the earth when you throw it under the projectile motion. So it doesn't accelerate forward because there's no forces acting on the object horizontally, but it does accelerate downward. In this case, it just imagine the gravity is in opposite direction. So it doesn't accelerate forward, but it does accelerate upward. So I have the distance, which is 1 centimeter that it will be flying, so it's 0.01. And the velocity is 3980 and 10 to the third because it was given in kilometers. So the time is equal to -9 seconds. So it is 2.5 nanoseconds. Maybe I'll just write 2.5 nanoseconds. So it will reach the screen in 2.5 nanoseconds. So I found the time it's going to take for the charge to reach the screen. Now I can find the average vertical velocity. So the distance the particle travels or the charge travels is vertically 0.2 centimeters. And I can find the average vertical velocity because when it leaves the machine, it leaves at some initial velocity that they give you, 3,980. But the vertical velocity doesn't have any vertical velocity. So to find that vertical velocity, and I'm going to call it vertical y velocity, is equal to its vertical distance, maybe call it h, the height it travels, over the time. So I get 0.002 meters divided by 2.5 nana negative 9. And that will give me the average vertical velocity is equal to 0.8 10 to the 6 meters per second. So if the average velocity, so let me write maybe the formula again. Average velocity is equal to the initial velocity plus the final velocity divided by 2. So because initial vertical velocity is 0, then the final velocity on y is equal to twice the average velocity, which is 1.6 10 to the 6 meters per second. Since I know the change of the vertical velocity and I know the time, I can find the acceleration vertically. So the particle is going to be accelerating in this direction. So I can find the acceleration is equal to change of the vertical velocity over the time. The initial vertical velocity is 0 and the final is 1.6. So it's 1.6 10 to the 6 minus 0 divided by the time it took, which is 2.5 nanoseconds. And acceleration is equal to 0.64 10 to the 15 meters per second squared. To compare this acceleration to the speed of light is the 10 to the 8 meters per second. So your acceleration will not last for more than 1 second. You can see that the time it takes here is 2.5 nanoseconds, so it will never reach velocity, even though the number looks very big for comparing to the speed of light, the acceleration. And now when I found all this information, I have to think, what do I do? How do I find my charge per mass proportion? And when I look at this problem, I see that the acceleration happens due to the electric field force. And your test point is the charge that they shoot out of the machine. So I can say that the net force is equal to ma, and in this case, the net force is your electric field force. So the electric field force is going to be equal to electric field times the charge from the formula of the electric fields. And that is equal to mass times acceleration. I just found acceleration. I don't know what the charge is equal to. I don't know what the mass is equal to because they didn't tell me what kind of charge it is. But they did give me, through the experiment that I was trying to figure out which electric field will give me exactly this landing for the charge, this position of landing of the charge. So I can find the charge per mass is equal to acceleration over the electric field. So the acceleration is 0.64 10 to the 15, and the electric field is 1800. So the charge per mass for this experiment is going to be equal to 355.56 10 to the 9th, and the measurements is going to be coulombs per kilogram because it's the charge per mass. So this is a very good resource to use for your preparation for AP Physics, and again it's taken from Monterey Institute of Technology. So you have to Google Monterey Institute of Technology and look up for AP Physics 1 and AP Physics 2. Thank you for watching this explanation of my problem solving, and I will see you in the next video.